Yay! So, today is the 19th, supposedly. Yes. Okay, and we are going to be doing GCF, greatest common factor. Okay. There are many different ways to do this. This is a method that we're going to use something called factor trees, which factor trees have been around since I was in school. In the end, though, is where it kind of does some weird stuff. The method to this makes it where you're really only having to worry about usually smaller multiplication tables, like 2s, 3s, 5s, 7s, 9s, the prime numbers. Okay, so here we go. So on today's worksheet, we started copy and vocab, but we are not totally finished. They were working on this. I know, good old fifth period. You get to listen to me reteach it real quick. They were working on this, and then tomorrow I will put it back up here. But what we're doing is we're going to start working on GCF on this side. And I just kind of want to show it. Okay. Problem is we're trying to save copies, and now stuff won't fit on the worksheet. So next time we won't save copies. Okay. So here we go. We're going to work on 14 and 20 to find the GCF. Okay. Whew, here we go. Now, all we're doing is starting out by using our multiplication tables to make what's called a factor tree. Okay, so I'm going to start with 14. Honestly, I know 2 times 7. That's it. Like, that's the only thing that equals it, right? Okay, are 2 or 7 prime? Yes, they're both prime. So we can circle anything that's prime. It's kind of like where my tree branch ends. It's like a tree growing and it stops with a leaf. Okay? The prime numbers, if you just want them on your paper, that we will mostly work with are 2, 3, 5, 7, 9, 11. I don't think we need 13, 17, and 19, but I will list them just because I'm videoing in case something weird comes up on our worksheet. Okay. I doubt we'll go that high, but if you need it. Okay, and I need you to know, prime numbers go on forever. It's just, we just need the low ones. Okay? Okay. So I found a multiplication table that equals 14, circled the prime numbers. Now, what's a multiplication table that equals 20? 10 times 2. Okay, and it doesn't matter. If you say 4 times 5, that is fine. Okay? Are either one of those prime? Yes. 2 is, right? So I'm going to circle the 2. But 10 can be broken down again to 5 times 2. Okay. Are either one of those prime? Yes. Yes. 2 and 5. Okay. Yes. It's okay. Just ignore it. Now, so let me show you a trick. Here is the plan. With GCF, we are looking for matching numbers. Numbers that are in both trees. They got to be in both trees. Okay. So, do y'all see that this 2 is in that tree? And there is a 2 in that tree. Now listen, if I highlight one here, it's kind of like I got to highlight one here. I don't want to highlight both, just one. Okay? So I'm going to list that down here. Does anything else match up? No. So guess what? This is easy. That is the GCF. There is what I'm going to call no more math involved in that one. Only in that one. Okay? Like most of them have more work to them. Okay? Yes. If you know it, yes.
So the way I'm doing it is I'm writing them down, like writing them down, putting them side by side, and whichever one is greatest, I circle the closest I can get.
That is fine. Like, the way I've normally taught this is listing every multiplication table that equals it. But what happens is kids will miss, let's say in the middle there's like an 8 times 9. And if you missed the 8 times 9, you might have missed the GCF. What this does is makes you catch every one that's possible. It's weird, but it works. Yes?
I don't see how you get
Your answer's going to come from, and in a minute it's going to change, kind of, but your answer's going to come from the stuff that matches. So like there was a 2 in this one and a 2 in this one. So I need to bring it down here. That on this one, that's your answer. I'm going to be honest. If there was a 7 over here, we would have to highlight both 7s and bring it down here and do 2 times 7. But we're not there yet, so don't worry. It's okay. So right now, that's our answer because it is the only thing that matched.
So when
Writing notes is not helping you. Go ahead.
when they're both the same number, like on each side, when they're both the same number, that's your answer?
Kind of, but in a second you're going to see a little different one. Since this is our only thing that matches, yes, that's our answer. Okay, so let's do another one. I'm actually going to skip down to number 3 on the notes because number 2 ends up being the same way with only one answer, or with only one thing highlighted. So I'm going to jump to number 3 and do 45 and 30. Okay. One sec. There we go. 45 and 30. What multiplication table equals 45? 5 times 9. You could do 15 times 3. It does not matter. You would get the same thing. Okay. Are either one of these prime? 5. But 9 can break down to 3 times 3. Okay, and they're both prime, so I need to circle those. I have finished each branch with a circle. That's the key. Okay, now I'm going to go to the 30. What equals 30? 3 and 10? Okay, you could do 5 times 6. It is fine. 3 and 10. Circle a 3. 10 would be 2 times 5 or 5 times 2. It doesn't matter what order you go in. We're all going to circle the same thing. Okay, so slow down, slow down. Okay, GCF. We're looking for matches. Now listen, you got to find all matches. So I have a 3. So what I'm going to do is write 3 and a times sign. Here is why. The 5s also match. The timesing of those numbers, those don't match. The timesing of those is what gives us the GCF of 15. Greatest common factor. So if there's 5 things that match, you got to multiply all 5 out. If there's like 10 things that match, you have to multiply all 10 out. Yes? Okay, the 2 3s, there's a 3 in each tree. There's a 5 in each tree. So for every match, you need to write it down here and multiply it out to get that final answer. For every pair of matches, you want to write it down and multiply it out. Okay. Yes.
But for 45, you can also do 15 times, or 3 times 15.
Yes. And then the 15 would break down to 3 times 5.
Oh,
Here's the key. This is the whole weird thing about this. As long as you keep breaking it down to prime numbers, we should all get the same thing. Okay. Think about that. Okay. So number 4. It's 36 and 54. Okay. So you break down 36, just 36. See if you can do it.
6 times 6.
I said you do it.
Oh.
Sorry. Keep going. Circle your prime numbers as you reach them. Do it. Write it. Oh, good. Now do 54 if you know it. Okay, so I want to show you something. I know he said 6 times 6, but I want you to see something. I'm going to start mine with 12 times 3. And then I'm going to break down the 12 to 4 times 3. I'm going to break down the 4 to 2 times 2. I need you to all realize it does not matter how you break it down as long as on your paper right now you have 2 3s and 2 2s. You might have 3 2 3 2. You might have 2 2 3 3. You might have 3 3 2 2. It doesn't matter as long as you have those things circled. It doesn't matter what order as long as you got them circled. Does that make sense so far? So you can see now how the different multiplication tables work, okay? Someone over here, most of you would do 6 times 9. I'm going to do 2 times 27. I'm going to circle the 2. I know 27 is 3 times 9. Circle the 3. 9 is 3 times 3. So under the 54, as long as you have a 2 and 3 3s, it doesn't matter what order. Okay, yes. But listen, 6s aren't prime, so you got to keep breaking down 6 to 3 times 2. You can't stop a tree limb until you reach a prime number. Yes. Right. You have a 2 and a 2 and a 3 and a 3, right? You should. 9 breaks down to 3 times 3. So you got, don't you have, what'd you start with? 36, then what? I'm sorry, I can't hear you. Say it again. 4 times 9, yes. Okay, 4 times 9. Then this breaks down to 2 times 2, and those are prime. 9 breaks down to 3 times 3. Listen, it doesn't matter how you got 36. Look at hers and look at mine. 2 2s and 2 3s. Same thing. 2 3s and 2 2s. As long as you got the same amount of numbers I do, we're good. Okay, now to create the GCF, I got to find all the matches or all the pairs or whatever you want to call them. Okay, here we go. I see this 2 and I see that 2. Notice I only highlighted it once just because I can't do it more than once. Okay, this 3 and this 3. Okay, here we go. This 3 and this 3. And that 3 and 2 won't work, will it? So 2 times 3 is 6 times 3 is 18. The GCF is 18. The GCF is 18. I want to show you a trick, even though this has nothing to do with, like, this is why we're learning this. Let me show you something. Okay. Look at something. What if you had the fraction 36 over 54? I'm going to be honest. Even lazy Miss Donahue would probably look at this. Can y'all see it? Okay. And divide by 6. Because I know that 6 goes into both of them. Then I would divide by 3 and get 2/3. Here's the deal. Way back here, if I had divided by 18, the GCF, I would have gone straight to 2/3. So if you can't find a GCF, if you can't simplify something, that's what this is teaching you, is how to find something to simplify by. If you can't find anything else, you can at least do this method, okay? All of us, like I grew up at least doing the tree thing and circling the prime numbers. What I didn't grow up doing was the very last step. So that is, like, that's kind of the newer style, okay? Let's do another one. Listen, if you will, I want you to look. All I'm going to do is go to the back. Okay, now, before you flip out, please listen. Okay. Your homework is 1 through 10. But I'm going to be honest. Right now, I'm going to try to help you with a few of them. So, 1 through 10. Nothing past 10, just 1 through 10. 1 through 10. You can X out the rest if you'd like. I am asking just to do 1 through 10. Okay. Now, if you want to keep going on that notebook paper, that's fine. I just ran out of space, so I'm going to a new sheet. Okay. If you'd like the back, that's fine. My pens are just bleeding through too bad, so. Okay. No, I'm just doing that for my sake. So if anybody's wondering what we're doing. Okay, so we're going to be doing 1 through 10. And like I said, I just can't fit it on here. If I do these factor trees, maybe if you turned it sideways, but I just can't. Okay. So I'm going to kind of set it up. Number 1 is 15 and 105. And I will say, if you're watching this video and you're in first period, we have kind of worked out the stuff that didn't work out so good this morning. If you'll kind of hang in there and keep watching, it will probably click. It will get easier. Okay. Breathing. Okay. So, start out. Number 1. Number your paper, number 1. Okay. Now, start out with just 15. What multiplication table equals 15?
3 and 5.
3 and 5. Yes, 3 times 5. Here we go. So I list it. Are they prime? Yes, actually both of them. That's it. I mean, I'm done with that number. Okay. Something like this. Guys, I keep saying the smaller prime numbers, but look at this. This should tell us one thing that for sure goes into it. 5. So if nothing else, I'm going to do 5. How many 5s are in 10? 2. And then into that 5 would be 1. So 21. Okay. Is either one prime?
5.
The 5. Okay. What equals 21? 7 times 3. Yes. 7 and 3 are prime. Good. So this one's kind of shorter and sweeter, as I call it. Okay. Now, I'm going to start looking for my matches to make my GCF. Okay, I see a 3.
5.
And I see a 5. You don't have to do the color thing. I'm just being silly. But if it works, use it. Okay. Now, make sure you multiply them. That's going to be the key. 3 times 5 is 15. And so our GCF is 15. Okay. It will start, like they may even repeat, but it does start looking, it feels like you're doing the same thing, but listen, that's because these factor trees, they're all going down to prime numbers. Most of them are going to be 2, 5, 7, or 11. So you're going to see 2, 5, 7, 11 constantly. Okay, let's do number 2. How about you try number 2? I'll give you a few minutes, and then we will compare what we get. It's 36 and 84. Pause it for just a second. The first one was 15. Is that good? Okay. It's okay. I just want to. It kind of, we're talking about this, how this makes it simpler, like the 84. Listen, it does not matter what pattern you do it in. So kind of watch. Like if I do 84, I honestly, I see this as being even. So I think of a 2 times something. You don't have to, okay? 2 times 42. Then I take this and I think, oh yeah, 6 times 7 is 42. Then I think 6 is 3 times 2. And I've got all the numbers. I've just kind of pulled them out. Now listen, it doesn't matter what order you have them in. We're on video, so watch the video. Okay. It doesn't matter. As long as under your 84 you have a 7 and a 3 and 2 2s. It doesn't matter what order you did it in. Does that help a little bit? Okay. So like on this one, if you do 12 times 3, okay, and then this person does 4 times 3. And then, or 6 times 2. Oh, 6 times 6 up there, yeah. So as long as under the 36, you've got 2 2s and 2 3s. Okay? Yes. Yeah. Right? A 3, a 2, a circle of 3, circle of 2. And then the other 6, you got to circle another 3 and another 2. So listen, you did, like, actually it's the same number that's up here. Look, you did 6 times 6. But neither one of those are primes, so you haven't circled them. You got to do, there's one of them, but you've got to do the other one also. Now, if you look at this, there's 2 3s and 2 2s. Just like on mine, they're just in a different place. 2 3s and 2 2s. Okay? So, if I go through and highlight the ones they have in common, here we go. And it doesn't matter which one. I can do this 3 and this 3, as long as I write 3 down there. I can do this 2 and this 2, as long as I write a 2 down there. I'm out of colors. Okay, I can do another 2 and another 2, as long as I write times 2 down there. So, I'm looking, there's a 3 and a 4. Can't circle anything else. So 3 times 2 is 6, times 2 is 12. That means my GCF is 12. It just, honestly, this method, it does take a lot of paper, but for kids who maybe don't know all their multiplication tables very fluently, perfectly, it works. Okay? Let's do number 3. I got 90 and 30. So try it. 90 and 30. 90 and 30. 90 and 30. Okay, you're done. Because there's nothing else there's no more little leggy things to get out. Right? Circle the end of that branch. Circle it, circle it. So now do 30. Yep. Once you've reached circling all the ends of the branches, you're done with that number. Listen, don't erase. As long as you have 2 3s, a 5 and a 2, doesn't matter what order, as long as you got those numbers. A 5, a 2, and 2 3s. Okay, this one. 9 can break down to 3 times 3. Yeah. That's why, we can't circle it. Whoops, that was prime up there. We can't circle them unless they're prime. No, 9 has 3 times 3.
30 times 3. Oh, you said 9 times 3. It's 30. Yeah.
No, not on my list. Is it on the other list? 1 second, let me see. Oh, woo! Okay, listen. Mark this out. It is not prime. I was just skip counting by odd numbers. Look. 2, 3, 5, 7, 9 is not prime. Woo, I make mistakes. Thanks for catching it. 11. Yeah, 13, 17, 19. 9 is not prime because it has 3 times 3. Woo, I'm glad you caught that. Listen, I make mistakes. Okay, so go back to this one. Let's check it. We should have highlighted or circled. Here's a 3. Here's a 3. Let's see. It doesn't really matter. Here's a 5. Here's a 5. Here's a 2. Here's a 2. I'm actually out of, there's no other numbers circled. So, 15 times 2? 30. GCF is equal to 30.
I added it up like 10 times 3 is 30.
Okay. Now, I will do one more. Otherwise, keep going. I'm kind of doing this for my first period group that wasn't able to watch the whole thing. 8 only has 3 is prime, so you would circle the 3, and then you got to work out the other one. Okay, 3 is an oddball, but you do. I mean, Like, what he's asking is on number 8, there's nothing that equals 3. So you just circle it. But you got to figure out these. Yeah, you do. This one's even. An 8 is even. So if nothing else, 2 goes into it. But looking around and playing is not helping. Look at what I'm pointing at. Can y'all see it? That 8 is telling me it's even. So if nothing else, 2 goes into it. Start breaking it down by 2. Okay. You could, yeah. Or 78. 78. Yeah. That's like if you don't know anything that equals it, start with the easy numbers, like 2s, 3s, and 5s. Yeah, dividing it. Okay, number 4, 112 and 88. Well, to be honest, I know 88's 8 times 11. I know 8 is 4 times 2. And 4 is 2 times 2. Okay. Okay, so like 112. I don't really know anything off the top of my head that equals 112. So, all I'm doing is this. Look. Do y'all see how it ends in a 2?
Yes.
That means it's even. So if nothing else, you can take 112 and divide by 2. So, 2 times 5 is 10. 2 into 12? 6. So, you can do over here 2 times 56. If you can't do this part in your head, you may have to jot it down. Okay, 56 is what?
Even.
It is even, so you could do that again. What else should I write?
8 times 7.
8 times, I'll be honest, this is what you should write. You should know 8 times 7 is 56. You should know that one. Then you do the 8. 4 times 2. Then you do the 4. Whoops, I didn't mean to circle that. I'm going too fast. Okay, we got to find all the matches. Okay, there is no 11. There's a 2 and a 2. There's, y'all can quit packing up now. There's this 2 and this 2. There's, yeah. And if you skip one, the problem's going to be if you accidentally skip one, you're going to get your answer wrong. Okay? But listen, is 8 prime? No, you don't want to circle anything that's not prime. All these should be prime down here. So either 2, 3, 5, 7, 11, 13, and so on. Okay? Multiplying them out. 2 times 2 is 4.
8.
Times 2 is 8. Yes. Your GCF should be 8. Yes.
Oh, what you got a minute left?
No, if it was going to start with a 6, it'd have to be 12. 6 times 2 is 12. I know, but 261 is 122. 61 plus 61 would be 122. Matt Fesh, please stop. But she's like talking to me. That's all it is. Did that make sense though? 261. Like, if you add 61 plus 61, it'd be 122. You got it. I can tell by the look on your face. Finish through 10 tonight. You may go, I'm assuming, if the bell's about to ring. You may go. Uh-huh.